Hello again, everyone. It's time to look at solving systems of equations again. And recall from last time we looked at linear equations. So for example, I might have two equations, y equals mx plus b and y equals minus cx plus d. Those are just straight lines. And the solution, the x and the y that satisfies both of those equations, is the point where the two lines cross. All right, so those are linear equations. If I had three-dimensional linear equations, then I would have three planes coming together, and there would be maybe one point where those three planes come together, and that would be the solution to those three equations. Right? Now, sometimes planes don't come together at all, right? So, for example, the ceiling is one plane, the floor is another plane, and then this wall is a third plane. So there's a system, there's an equation for the ceiling, an equation for the floor, and an equation for the wall. Well, the wall comes together with the ceiling at this edge, and the floor and the wall come together at this edge, but they never come together at the same place. So remember, sometimes there is no solution to the system of equations. Just like if I had two lines that were parallel, there's no solution to that system of equations because those lines never cross. All right, but what happens when we get to nonlinear systems? When I get to nonlinear systems, things can become much more complicated. So for example, I might have a circle. So there's an equation for the circle, and then there's a parabola here. There's an equation for the parabola. But you'll notice that these two equations cross at four different points. So there's an intersection here and here and here and here. So the equations cross at four different points. So how am I going to get that system of equations solved? Well, you're going to have four solutions in this case. And that's going to be a little bit more difficult to discern. And there are several methods by which we can solve that system of equations. So in a real brief rundown, let's say I have a polynomial, right? And I'm looking for the root of that polynomial. Okay, so that's where the function f of x is equal to 0. That's the root of the polynomial. Well, what is that? Well, of course, there's three roots in this particular one. But maybe I know this root right here. Well, one of the things I can do is, if I'm trying to find out the x value for this, I might come over here, maybe this is equal to x equal to 5, and this is x equal to 6. And what I do is I look at x equal to 6 and I solve it. So this is f of 6. And then I do x equal to 5 and I solve for y, so that's f of 5. And what I discover is f of 5 is negative, f of 6 is positive. Well, okay, so the intermediate value theorem tells me, hey, there must be a root someplace between 5 and 6, because I'm going from negative to positive. There's got to be a root in there. And so what do? Well, then maybe I try 5.5. Well, maybe 5.5, I get a negative number. So I find then, okay, now I know the root is between 5.5 and 6. So then I try 5.75 over here. And I find out, hey, 5.75, that's going to be positive. So I know it's between 5.5 and 5.75. And I keep doing that. It's called the method of bisections. And that I didn't really bisect that second group, but you get the idea. So I look at this point, I look at this point on the x, one's plus, one's minus. I know it's in between. So I choose halfway in between. If halfway in between is positive, then I know it's between this point and this point. If halfway in between is negative, then I know it's between this point and this point. So that's called the method of bisections. And so it's a process, and I have to do it over and over and over again until I get a value that's close enough. So these are numerical approximations. I'm not going to get exact values like I might with a system of linear equations. I might get exact values, but I might not. So I'm using approximations. And that's what we have to go with. And it's called an iterative process. You do it once, you get positive and negative. You do it again, that's another iteration. You get positive and negative. You do it again, you get positive and positive. So we know it's back over here. So you're going back and forth until you zoom in on the actual solution to that problem. Well, so how do I do that in Excel? Well, for a nonlinear system, there's this thing called the solver. And with the solver, it uses an iterative process to find a solution to a nonlinear system of equations. So let's take a look. Here's an example. So here's a system of three equations and three unknowns. And I've got sines and cosines all over in here, right? So this is a nonlinear system, but I'm interested in the solution to this system. How do I do that? Because the solution is going to be when I have an x, y, and a z value that makes this first one equal to 0, the second one equal to 3, the third one equal to 2. But how do I find that system? So what we do in Excel is we have to set it up a little bit differently. And I'll give you more detail this when we walk over to the Excel spreadsheet. But what I'm going to do is I have the top equations already set equal to 0, so that one's pretty good. All right? And so I'm going to make the bottom equation, I'm going to say that's minus 3, because I'm going to bring the 3 to the other side, so that's equal to 0. And then minus 2, and that's equal to 0. So if all three of these equations equal 0, I must have a solution. Well, of course, I could have let it be 0, 2, and 3, but there's a reason for this. If they're all equal to 0, then it's going to be a solution. So let me call this one A, this is B, and this is C. Okay? There's A, B, and C. So if I take A plus B plus C, and they're all equal to 0, I'm going to get 0. So what I'm going to do is I'm going to say to Excel, hey, add up A, B, and C, and you should get 0. Well, now wait a minute. What if this was 5, and this was negative 2, and this was negative 3? Then they would add up to 0, right? But I wouldn't have this. It wouldn't be what I want. So how do I get them to be 0 by adding them together? The secret is to square it, so this doesn't work. So I'm going to take A squared plus B squared plus C squared, and I'm going to set that equal to 0. And that's only going to be true, OCD, that's only going to be true if A is equal to 0 and B is equal to 0 and C is equal to 0. This can't equal 0, we're assuming real solutions. These can't be all equal to 0 or add up to equal 0 unless all of them, each of them, is equal to 0. So they have to each be equal to 0 together at the same position in order for this to be true. And Excel will do that for us. All right, so let's take a break. I'll jump onto Excel and we'll see how that happens. All right, so let's take a look at what we see when we work with the spreadsheet. So here's my system of equations again. Okay, so all of this stuff, all of this stuff is the system of equations. And what I've done is I've got that system of equations up here. Here's equation A. So you'll see up here in the command line or the entry line, I've got the sine of E2, but E2 is x, cosine of y, minus the log of z. So that's all right up in there. If I go to the equation B, if I go to equation B, you can see I've got cosine of x, 2 times the log of y plus the sine of z, minus 3, right? So I've got that minus 3 in there. And then there's equation C, which is 3 log x minus the sine of y plus the cosine of z, minus 2. And what I want to do is I've set all of those equal to 0. So you'll see down here is a squared plus b squared plus c squared equals 0. So there's b4 squared, which is right there, and then b5 squared and b6 squared. So I've added all those together and set them equal to 0. All right, so how do I solve this system? So I go to what's called the solver. So I go up to data, and over here on the right you'll see solver. And you might have to add that in, which I didn't do in this video, but hopefully you know how to do that. I go to solver, and then I say, hey, I want to set cell B8, which is right here. I want to set that to a value of 0. So I've got to set that value of 0. And how am I going to do that? I'm going to change these 3 cells. Okay, so I think I just messed up, right? Okay, so let's go back to there. I'm going to change, I want cell B8 to be equal to 0, and I'm going to do that. Notice when I've highlighted by changing these variables, these are the 3 variables that I'm highlighting, all 3 of them here. All right. I don't want anything to be negative, so I'm going to make unconstrained variables non-negative because I can't do the log of a negative number. And I've got that set up so it's at a value of 0. And so I'm just going to hit solve, and let's see what comes up. Notice after I'm done with solve, this should be equal to 0. You'll also notice select a solving method. GRG nonlinear is what I'm using here. There are some others, but I'm just going to stick with GRG nonlinear. All right, so I go to solve. And you'll notice, hey, that's not 0, but it's closer than it was. And so what's happened here is GRG nonlinear has gone through that X number of times. I don't know what X is. Might be 100, might be 1,000. I don't know. But it's done it so many times, and then that's as good as it got. So let's run it again. I don't have to change anything in here. I just hit solve again. Okay, that's not working. Okay, so my initial guesses are not good. That's the problem. So I'm going to change my initial guesses. Remember last time I had it at 10. This is part of the process here. So I'm going to make each of these 1 instead of 10. And let's see what happens if I do that. So sometimes you just got to have some good guesses. And notice now, look at that, 1.35. Well, hit OK. 1.35 times 10 to the minus 6. That's pretty close to 0. I'll run it one more time just because I can. 10 to the minus 7 is getting a little better. Should we do it again just to see if we can get even better? I mean, that's pretty close to 0. All right, so that looks like that's as good as it's going to get, 9.84 times 10 to the minus 7. And that's good enough for me. So there are my solutions to x, y, and z in this system of equations right in here. Right, so I've got my solution to this system of equation. Here are my values for x, y, and z to solve that system. All right, if you have any questions on any of this, please do leave them in the comments below. Thank you.